Okay, so we're going to, in this video, graph a new function using transformations, but we're going to graph it using what we know about the parent graph and just do transformations from the parent graph. So in the last video, I graphed this parent graph for you, y equals the cubed root of x. Now we're going to look at the new graph, y equals the cubed root. Sorry, this is a little hard to write out properly with my finger. The cubed root of x minus 2, all under the radical, plus 3, which is outside of the radical. Okay, so let's do that using transformations. When we graphed the square root functions, we transformed the parent graph and we shifted left and right. What was under the radical determined our left or right shift, and this guy on the outside determined our up or down shift. Okay? So we're going to do the same thing here. When we were doing square root functions, we moved our starting point. That's what we were shifting. With cubed root functions, what we're going to be moving is our inflection point. In both cases, they were 0, 0 on the parent graph. So let's go ahead and start. We're going to move our inflection point. Well, this tells me right under here that if I set x minus 2 equal to 0, I'm going to be moving my inflection point 2 to the right. And I'm going to be moving my inflection point 3 up, because I have a plus 3 over there, and that's positive. By the way, what I'm doing right now is I am doing number 7 in your Unit 5, Day 5 packet. I'm just graphing that function over there. So let's go ahead and do that. Let's move this guy over. I'm going to move to the right 2, and I'm going to move 3 up, 1, 2, 3. So this right here will be my new point. Shoot, it looks like I'm going to be going right into my function there. So let me rewrite my function actually down here. Y equals the cubed root of x minus 2 plus 3. Let me erase him up there so that we have space to graph it. Alright, so let's graph it. We just moved our inflection point over. Now we're just going to graph as usual. We know that when we move to the right 1, the cubed root of 1 is just 1. Same as when I move to the left 1. Well, not the same, but when I move to the left 1, the cubed root of 1 to the left is negative 1. When I move to the right, let's see, 8, which is my next perfect cube. So that's 1, 2, 3, 4, 5, 6, 7, 8. When I move to the right 8, my cubed root is 2, a positive 2. Oops. So it's going to be right over there. And when I move to the left 2, 1, 2, 3, 4, or I'm sorry, when I move to the left 8, 1, 2, 3, 4, 5, 6, 7, 8. From this guy, I'm moving from this guy. I'm moving to the left on the x-axis, 8. 1, 2, 3, 4, 5, 6, 7, 8. My cubed root of that would be negative 2. So it's that point right there. So, to connect all my dots... Oh, I'm sorry. That's not right. I'm moving down also from this guy, okay? I'm not moving down from 0. I'm moving down from my new inflection point. So one more time. When I move to the left, 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm moving my inflection point down to 1, 2. So it's right here, okay? Yeah, it's right there. So I'm going to connect my dots. And that is my new and transformed graph, which represents this function right here. Don't get confused and do what I did. Remember that you are now moving from your new inflection point. So before, this was our inflection point. But since we had these, this horizontal shift 2 to the right and this vertical shift 3 up, we had to start moving from here, okay? So don't get confused and make sure that you graph your points according to the new inflection point.